Hi everyone, it's Sridevi, Professor of Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about detection theory, that is basic elements of detection theory and equalization techniques for optimum detection of signals in noise.
On completion of this module, the learners can able to understand the basic concepts about adaptive equalization techniques. So initially we have to know the necessity of adaptive equalization, that is in case of communication, most of the channels are made up of individual links. For example, the switched telephone networks, the distortion introduced depends upon two important parameters. One is transmission characteristics of important individual links and number of links in connection. Hence, we need a fixed pair of transmit and receive filters to serve equalization problem completely. For that purpose, we need adaptive equalizer. It is an equalizer that automatically adapts to time varying properties of the communication channel. So, the basic principle of this adaptive equalization is the filters first adapt themselves to a dispersive effects of channel, that is the coefficients of the filters are changed continuously according to the received data. It is frequently used with coherent modulation such as phase shift keying and the effects of multi-path propagation which includes the Doppler effect. The examples of this adaptive equalizers are zero forcing equalizer and minimum mean square equalizer and decision feedback equalizer. So the two main adaptation algorithms used are, one is least mean square algorithm and that is LMS, and another one is recursive least mean algorithm, that is RLS. The adaptive equalizers are zero forcing equalizer, as we said. The basic types of equalization are, it is done at the transmitting side and it is called as pre-channel equalization. If the equalization is done in the transmitting side, then it is called as pre-channel equalization, and if it is done in the receiver side, then it is called as post-channel equalization. In this first one, pre-channel equalization, this type of equalization requires feedback to know the amount of distortion in the received data. So the combination between the equalization types can made into one which is fit for some specifications, that is passive equalizer and active equalizer. The filter implementation using traversal of lattice structures, linear equalization, and some different equalization algorithms are used for this type of equalization. One is called as feed forward for FIR and also this type of equalization removes linear errors from the modulated signals by dynamically creating some compensating filter. So because of this compensation filter use, the errors can be compensated. Linear errors can come from the filters in a transmitter or receiver, in intermediate filter, or from the presence of multipaths in the transmission path. So the equalizers, it is a filter that compensates for dispersion effects of the channel, that is the adaptive equalizer can adjust the coefficients continuously during the transmission of the data. As we said, pre-equalization and post-equalization. Pre-equalization requires feedback channel, causes burden to the transmission. So initially the feedback is needed, it should be known first. It is a process of creating channel induced distortion. So to realize the full transmission capability of a telephone channel, this adaptive equalization is needed. So by using this adaptive equalization, we know that the equalizer that is said to be adaptive when it adjusts itself continuously during data transmission. So depends upon the data, the equalizer adjusts itself. There is no need of adjusting the system. The equalizer itself adjusts itself themselves. So this pre-equalization is used at the transmitter and post-equalization is used at the receiver. So pre-equalization requires a feedback channel and adaptive equalization at the receiving side considered. So this equalization can be achieved before data transmission. So before data transmission, in pre-equalization, it should be considered. And in adaptive equalization consists a tape delay line for 100 tapes or more than that, and its coefficients are updated according to LMS algorithm. So adjusted to the filter coefficients are made in this step-by-step fashion synchronously with the incoming data. But it is reverse in case of post-channel equalization. So it is happening at the receiver side, and it is achieved prior to data transmission by transmitting a filter with guidance of transmitting a training sequence transmitted through the channel. That is called as post-equalization. It consists of the taped delay line filter with set of delay elements. This set is adjustable to multipliers connected to the delay line tapes and summer for adding multiplier outputs. So this is the diagram for adaptive equalization. It is having the taped delay line C0, C1, C2, etc. up to Cm-1, and Xn of t is the digitized input signal. Delay t, first one is delay t. If it is delayed, it will be x of n of t minus t, and delay another t, that is n minus t minus 2 minus t, and n of t, x of nt minus m t plus 2 t, etc. Like this the delay will be have. The desired response is added, and finally we get the output. The modes of operations are training period mode and decision direct mode. So adaptive equalization equalizers are used in telephone channels. The telephone channel is made up of individual links. So the distortion for telephone network depends upon transmission characteristics of individual links and number of links in the connection. Hence, fixed pair of transmit to receive filters, we will not solve the equalization problem completely. So transmission characteristics of the channel keep on changing. Therefore, the adaptive equalization is necessary for transmitting channel. So here we have the one quiz question based upon adaptive equalization techniques. The question here is: working of adaptive equalization includes two. A is training, B is tracking, C is modulation, B is both A and B. So we know that the modes used are training and tracking. So correct answer is D. Both A and B are correct. Thank you.